Welcome back to KTAL LP, Las Cruces, New Mexico, Community Radio at 101.5 on your FM dial. Also streamed live at lccommunityradio.org and Radio KTAL, QUETAL.org. And on both places, you can find out about becoming a member and also about underwriting. Now, underwriting tends to target the whole station or specific programs. Right now, you're listening to Science Let's Take a Look. I'm your host, Vince Gucic, and this is an outreach activity of the Las Cruces Academy, and we've put in our pledge to be a supporter of the station, and particularly my show here. So let me put in a few corrections while I'm at it. This is the sixth show. The fifth show was sort of a recap because I had laryngitis. But I made a couple of claims. I mentioned Homo sapiens being 2 million years old, let's say 200,000, because there were other genus Homo during that 2 million years. I also mentioned that Thomas Edison was involved in a dispute over whether electric power transmission should be alternating current or direct current. And one of the stunning demonstrations was when a rogue elephant, Topsy, was electrocuted by AC. And I had thought that Edison was involved in that. He said he wanted no part of it. That was somebody else's idea. Another thing that I said was that 6% of our own human genome is bacterial and viral DNA. Well, the evidence for bacterial DNA being incorporated into our genome is pretty weak. But viral DNA, oh yeah, probably 6%. And these look like ancient retroviruses, the ones that integrate into our genome and stay there to become active. One of the examples there is HIV. Well, all of these old retroviruses in our genome are inactive, so they themselves have died, you might say. I've got time now for a small segment. I keep saying I'm going to do Have You Thanked a Bacterium today? That's got to be the next show, although we'll see how that comes up. It's a long segment. So let me do one about why is there volcanic pumice in Nebraska. So if you've ever used a kitchen cleanser like Ajax or Bon Ami or soap like lava, you've used pumice. Manufacturers dig this up and they grind it up into small enough chunks. Well, it's basically lava that had a lot of gas, especially water vapor, dissolved in it. And when the volcanic eruptions bring this hot rock to the surface quickly, the dissolved gases form bubbles, and then it all freezes. So you've got a rock with lots of empty space, well, gas, and it's light enough to float. It's also excellent for cleaning sinks and hands as an abrasive. So the big mines for pumice were in Nebraska. That started in 1897. Well, if you've been to Nebraska, you won't see any volcanoes. So where did this pumice in layers about a foot thick come from? Well, it had to be from a volcanic eruption, and a big, fast one. Only fast, explosive eruptions can create the pumice. They do it in what's called pyroclastic flows, something you don't want to be anywhere near. It's an enormously fast wave of air and pumice running down a volcano. It also comes in big clouds, erupted high into the atmosphere and sorting out later. So this eruption came when there were rhinoceroses and camels in Nebraska 640,000 years ago. And, of course, we found their fossils. So how do we know it was 640,000 years ago? It's using a really neat technique called SHRIMP, Sensitive High-Resolution Ion Microprobe. So you can aim a beam, I believe it's electrons, at a sample and vaporize some of it, and then use a mass spectrometer which accelerates some of these elements as ions, bends them in a magnetic field, and how much they bend will basically tell you what the mass is. So you can measure the ratio of uranium to lead as the uranium decays to lead. And you can find the best samples in little zircon crystals that's solidified as this thing erupted. So, cut to the chase. U.S. Army Lieutenant Gustavus Dohn, back in 1870, noticed that a 60-mile-long chain of mountains was missing around Yellowstone National Park. Now, I'm not sure how he says it's missing. Why was he expecting him? But anyway, more recently, geologists traced the ash deposits, and they also saw that Yellowstone Lake was slowly sloshing to one side. And then they finally saw a satellite image, and they said, this is the classic shape of a caldera, meaning it covered the entire Yellowstone Park. This whole story is told nicely in Smithsonian Magazine in the July 2004 issue and the National Geographic issue of August 2009. So that part of the story is very interesting, but here's something that's a little more edgy, that it appears that Yellowstone recently has been erupting about every 600,000 to 650,000 years. Well, the last time was 640,000 years. Are we overdue? There is a huge magma chamber under Yellowstone right now. Is there anything we can do about it? No. But, of course, if it does erupt, that's the end of most of the U.S. But don't worry about it right now. And, again, nothing you can do about it. There are other monstrous volcanic eruptions that have occurred and have affected human populations. Well, Krakatoa erupted in 1883, and Tambora before that in 1850. They spread ash and sulfur dioxide worldwide. They also killed tens of thousands of people locally. But 1816 became known as the year without a summer around the northern hemisphere because the ash and the sulfur dioxide aerosols blocked enough sunlight to cool the entire climate. And freezing weather occurred in every month of the year in New England. That means crop failures. Now, there was an even bigger eruption 74,000 years ago, Toba in Indonesia. And there's some controversy about this, but it appears that it really left the mark on our human genome. Some people say that we probably had a world population of several million at that point, but maybe only 10,000 or fewer of us survived that massive eruption. We went through a bottleneck, a small population size. One of the things that happens, as has been seen in cheetahs, small population, you reduce the sampling of genetic diversity. Well, we're fairly diverse now, and there's lots of discussion about that, but we're not as diverse as we should be for a population our size. You could say that Toba has marked us. Going back to what else volcanoes do, they do bring benefits in the longer term. We've got really nice, fertile soils in many places because lava brings critical minerals to the surface. Hawaii has lots of volcanoes, and especially the older islands where they've weathered these lava deposits, they're very fertile. Australia, in contrast, has been pretty quiet for about 150 billion years, and it has the most bizarre array of soil mineral deficiencies in the world. You name the element, and you can find a place in Australia that's deficient. And who knows that? The pastoralists who are trying to raise sheep, and they find a place with not enough cobalt. So volcanoes also brought us out of Snowball Earth 2.2 billion years ago, but that's another story, and we'll go over that story sometime very soon. So overall, I guess you could say that we're grateful that most eruptions are rather benign on average and even useful. And all we have to do is be careful about being close to them when they're erupting. So we have friends in Bali and Sulawesi who have been experiencing the threat of volcanoes. So we have our concern for them. let me go off on another thing here. Tell me what you'd like to hear next. So I have a whole lot of possible shows. One of them, as I said, is have you thanked the bacterium today? Another one is, well, let me get the list. Okay. Where did I put it? I left it out in the other room. So there's a foray into oxygen. There's the functions of blood. There's what is the risk of carbon nanotubes. I've got so many that they're all clogged up in my mind. We do biology, we do chemistry, we do physics. So if you want to suggest something or pick any of those things that I've just mentioned, you can text my phone, which is 575-571-2269. You can email me, Vince, V-I-N-C-E, at loscrucesacademy.org. Or you can go to my website and leave a comment. I have science-technology-society.com, where you can also find links to recordings of all the previous shows. And you can also look at the website loscrucesacademy.org, which is the organization where I'm the board chair and for whom I'm doing this as outreach. And I will sign off here. But before I do, again, let me remind you that you can become a member or an underwriter of this show. You have a wide reach here if you get your message out on KTAL KTAL FM. We cover about a 10-mile radius all around the city. Yeah. So we hope you will consider membership and sponsorship, and I hope you will tell me what you want to hear. I hope you like what you hear. Give me comments, and I hope you will come back to listen every Tuesday at noon for Science Let's Take a Look with me, Vince Gucic, as your host, and we will see you next week. Goodbye.